Much, Sean, and greetings, everybody. I'm Richard K. Shaw, and I serve as the state soil scientist for New Jersey and New York. And I'm going to start out giving you a brief introduction to our Urban Soils Focus Team, what we are charged with, and then we'll talk about soil survey activities in 4 different cities. And I will talk fast because I'm going to try and get through this in 5 minutes. But the Soil Science Division has 13 focus teams, and they're set up to deliver soils information on selected topics to the soil survey user community while maintaining the high quality of that information. And our Urban Soils team consists of myself and Randy Riddle from the Templeton, California Soil Survey Office, which covers Los Angeles, serving as co-chairs. We've got Eric Gano from the Flint, Michigan Soil Survey Office, which covers Detroit, and Christine Ryan from the Aurora, Illinois Soil Survey Office covering Chicago, and us 4 will be giving the presentations today. Other members of the team include Kenny Hall from Rosenberg, Texas, which covers Houston, Ralph Tucker from Union, Missouri, which covers St. Louis, and Jacob Islip from Tolland, Connecticut, which covers New York City, Northern New Jersey, and the Boston area. And we are still taking new members to the team. You don't have to be from NRCS. So if there's any interest out there, please let one of us know. So I'm going to start out saying a few words about urban soil survey. And there really have been and still are some disincentives to urban soil survey. The first soil surveys were designed to guide agricultural productivity. Many of our soil scientists have a farm background, so urban areas are really non-traditional with regard to soil survey. In fact, many of our earlier surveys drew a line around the urban areas and didn't map them. Okay, granted, there are problems. The soils can be a mess. They can be very variable. Logistics working in an urban area are difficult, so they generally take more time and money per acre. And when you're using the number of acres to measure progress, that's a problem. But on the bright side, there are definitely incentives. First of all, this is where all the people live in the U.S. The USDA used to be the People's Department when it was first started. Now, granted, not as many people are involved in agriculture anymore, but if our agency has something to offer the 80% of the population, shouldn't we do this? Urban sprawl is an issue. We've got a little fact there from Dave Huber of the National Soil Survey Center, which says we've got 27 million acres in our soil survey database with some urban land component. Urban soil survey is a real leadership opportunity for soil survey. If we don't do it, somebody else is going to step in there and take over, and who's better suited than we are? There's a lot of opportunity for new partnerships and customers. And I always like to say, instead of looking at the number of acres, we should look at the number of taxpayers per acre, because we can also always use more public support. Okay, looking at some of the charges for our Urban Soil Focus team, probably one of the most important is the education and outreach aspect. People in urban areas are generally unfamiliar with our agency, with soil survey, soil ecosystem functions. So we really need to get the word out there. We attend conferences, meetings, workshops. Randy and I were fortunate to attend the International Urban Soils Conference in Moscow with the SUTMA group. SUTMA stands for the Soils of Urban, Industrial, Traffic, Mining, and Military Areas. It's the Urban Soils Working Group of the International Union of Soil Sciences, and NRCS members have attended it for probably the last 10 years. I've also attended some soil-related events in New York City, where I can say from experience, soil science is alive and well to promote the survey. And we've got some publications describing urban soil survey and urban soils. We've got a chapter in the new soil survey manual. We've got several NRCS contributions to Soils Within Cities, which is a book produced by the SUTMA group, very affordable at 30 euros. And we've got in review a new publication on soil systems of New York City, which describes the city soils and is really an accompaniment to the survey. Another of our charges is to put together the existing soil survey data on a website. Our agency has completed quite a few urban soil surveys rather recently. There may be similarities in properties of urban soils, but like Professor Czarzinski of Poland says, the urban soil pattern is unique for every city, and our surveys will have different soils, different map units. The idea here is to show soil scientists and land use planners, urban environmental professionals, what kind of information can be provided by soil survey. Another of our charges is to identify any update needs, soil taxonomy or description, characterization, lab analysis, database population for urban soils. Are we missing anything? Can we do anything better? Since we are the ones using the systems, we're probably the best suited to suggest some changes. A couple of examples, the greater than 2 millimeter fraction in soils. Urban soils often contains carbon, but that fraction isn't included in the lab analysis. So are we underestimating carbon sequestration in these soils? And are all of the artifacts looked at in all of our interps? Is there something we may be missing? And lastly, one of the charges for soil survey is to keep the survey relevant to changing needs. So it's our job to make sure soil survey information is appropriate for urban applications. And this will probably involve working with the soil interpretation staff, and we actually have a few things in the works. We have a technical note on urban soils and agriculture, and we're working on modifying the land capability class to rate soils for urban agriculture. So I think that's enough for me for now, and I'm going to turn it over to Eric, who's going to tell you about the Wayne County Urban Soil Survey.
Good afternoon, everybody. I said I'm Eric Gano. I'm from Flint, Michigan. We just finished the Detroit Soil Survey in January. It was February, I guess. It was posted to the Web Soil Survey. I'm going to go quickly over, I guess, what some of the things we found and some of the challenges we had and how we chose to overcome those. A little history quickly. The original Wayne County Soil Survey was Wayne County area. It was felt that we couldn't produce an accurate map in the heavily urbanized portion of Detroit and the surrounding cities. So when it was published without about 171,000 acres of the county were just left as unmapped edge of soil survey. When about 2009 or so, we started getting word that we're going to look into mapping in Detroit. So we started looking at base materials, and we discovered that we really don't have one. The photography was just inaccurate. We couldn't see anything. There was too little relief in the area. In order to stereoscope accurately, the artificial drainage in the area obscured all of the moisture signatures on our infrared photography, so we needed something new. And we suggested we needed LiDAR. And I guess to our surprise, the state jumped on board, and they got together with state, county, city governments, other federal agencies, and they got LiDAR flown for us. So while we were waiting for all of the paperwork to be signed, we started looking at historic data, and the most recent, soil-related map was the Geologic Atlas of the United States from 1917. We started out with that. It gave us a pretty good idea on where the textures might be changing, where the soils might be changing across the area. We went and dug into EPA and the Department of Environmental Quality Studies. We went to the Department of Transportation. They had engineering borings for the highways. We contacted the city governments, got their engineering borings, research papers, consulting firms, everybody we could get our hands on. We grabbed the LiDAR, and we decided this is a perfect base map for us. We derived a hill-shaped map from the LiDAR, gave a little exaggeration because the area is flat. It's a lake plain. Well, sort of. This is my favorite example of using the LiDAR versus the true color imagery. This is the same area on the in both pictures. You can see here, there's a big drain running through this area that used to connect up to the River Rouge, main river through Detroit. And on the true color imagery, you can't see it at all. It's nothing but houses and unfortunately for these people, because it does flood whenever we get a heavy rain. You can also see a beach ridge that runs up through the west side that doesn't show up in the photography, a floodplain terrace that's now nothing but houses. So this LiDAR coverage really did make the difference and allow us to get in there and map in the city of Detroit. We had to decide how we were going to map. We decided, well, the auger descriptions are always going to be our bread and butter. So we're going to go ahead and do that. The only difference is we brought a tarp and a 5-gallon bucket with us. You know, cut the sod off, throw everything on a tarp, describe it, fill it back in. Over here on the right side of the photo, you can see after we left, you know, we plug everything back up, and that is not my best work, but there wasn't enough grass left to fill it in all the way. At every one of these stops, or nearly every one, we devised this field note card. This is a typed version of that note card. Gives us our locations, our land uses. Over here we've got a spot to do a profile of the human transport material, the fill on top. Our goal was really to get a good description of the fill and the natural soil profiles, so we know what soils were there before they were either truncated or filled. So any information we possibly need, and we had 2,600 of those when we finished. Soil pattern descriptions were done pretty much the same way as anywhere else. They did have to be a little smaller, mostly because of time. Just you're looking at an hour and a half to 2 hour drive one way. There isn't a lot of time to open a pit, sample it, describe it, and fill it back in, and get home, that same day anyway. So that really didn't change a whole lot. The biggest issues we had in Detroit were the large number of landowners. The majority of the area is residential. So getting access, and even when you could get a spot that looked nice, it was all landscaped, and people get pretty grumpy when you start digging holes in spots that they've spent a lot of money on. So how do we overcome that? Well, the cities all gave us access to all the right-of-ways, their parks and schools, anything they owned. The county land bank, we had permissions to dig on property that they owned. This picture on the left you see is a park in the city of Dearborn. Other than that, we just drive the streets until we found a place to dig or something that was open. If we saw the safety fencing, construction safety fencing, we'd make a beeline right for it, because that meant there was a hole in the ground that we might be able to get a look at. This is a water main project that's underway. We followed that one for several blocks down, chasing the thickness of a sandy cap until it disappeared. This one on the right was an abandoned home that had been demolished, and the foundation had been removed, and they'd actually dug the opening far enough back that we could actually see the natural soil along the side of that hole. So anything we could possibly use to get a look at what's under the ground, we took. Beyond that, working with the local university, Wayne State University, they were doing a lot of research projects on urban soils. They were more than happy to help us. They'd come out and dig holes for us. Some of our larger pits, and the majority of our pits were actually started by Wayne State University grad students. They'd start digging before we got there, and we'd help them finish up and describe it, and we'd all fill it in and go home. The Environmental Protection Agency, they showed up with an urban project on infiltration and runoff in these vacant lots. We followed them around for several weeks. That gave us a huge amount of information. But once we were done with all of that, finally found enough, in Detroit we decided to map the natural soil composition first. We created a map just like we would anywhere else, then grabbed an impervious surface layer given to us by the Southeast Michigan Council of Governments, and we used that to get the percentage of urban land within each polygon, within each map unit, and we split it up after analyzing the thickness of the fill on each soil and each landform and each land use, and the types of those human transported material, the percentage of impervious surfaces, and then joined the surrounding surveys with what we had. We did have points outside our area in order to actually be able to join what was coming in the urban sprawl. Just a real quick notes on this is what we found was that our fill material was generally from the sea horizon and the surrounding area. In the residential areas, we weren't even buried. We don't meet the classification for buried soils, so we were mapping natural soil series phased with a human transported surface. Relatively low in artifact content, mostly glass. We did find our parks and schools were deeper buried stuff, which I guess makes some sense, keep them higher and drier. The commercial areas, well, things got deeper. The fill got thicker. The number of artifacts, the amount of artifacts went up dramatically. So, yeah, a little surprising that our residential areas didn't have the fill we thought they would. In February, this got posted. This is an image straight from Web Soil Survey of Wayne County. The Detroit, let me get this thing, the Detroit survey boundaries roughly in there like that. It's the eastern and northeastern part of that survey area. So hopefully it blends in pretty well. And these last couple of slides here I put in, these are the slides that people have been really interested in that I really didn't think anything about, is the dense material, the depth of density material, and this one here, the surface water management systems. When we started Detroit, we were thinking the cities would want to know about putting in utility lines, maybe the urban gardeners, urban farmers would want to know something, but the most response that I've gotten is from people with doing green infrastructure planning, trying to get rid of stormwater before it hits the sewer systems. So the sewers in Detroit are 80 to 90% integrated between the wastewater and the stormwater. Getting that water out of the system is huge, and knowing where that dense till is and where they're going to have to put extra money into removing the stormwater seems to be, it's key for them. That was a big thing. As far as opportunities that I've had, so we only finished this in February, so there hasn't been much. I have been asked to be on this urban mapping focus team. I've had several opportunities to speak to the Department of Environmental Quality. I was asked to speak at the Great Lakes and St. Lawrence Green Infrastructure Conference held in Detroit. It was a conference for all the cities from Duluth over to Quebec and both sides of the border to speak about getting rid of the surface water runoff before it enters the Great Lakes. And that was a great opportunity for me. That and making a lot of contacts with other agencies and universities. It's been very good for us. But that's my quick little presentation. I'm going to turn this over to Christine Ryan, speak a little bit about Chicago.
All right, I'm going to talk a little bit about our methods and how we went about mapping Chicago. The interesting thing about it was after we finished, it came out with all the new classification for urban. So our classification is now out of date, which is fine. It's just new projects, I guess. So we had originally originally we started the update process. Let me go back a little bit. So right here, I have these arrows to show where they stopped mapping back in the 70s. And there was literally a line drawn that says the limit of detailed soil survey. And this is about 300,000 acres. It's like 299,000 something. So total acreage is about 600,000 for Cook County. So half was mapped and half wasn't. And in 2007, 2008, we had an MOU signed where we were just going to do the update of the map part. Well, while we were updating it, somebody had reached out to the state soil scientist at the time and was interested in getting this whole map. And so somebody in the GIS department in the Cook County government was trying to do some stormwater management planning, I suppose. And he noticed that there was zero soil information for about half the county. And obviously urban land is not rated, so there's nothing. So we missed a lot, and the MOU was signed, and we started the work. I think it was in the fall of 2009, I think. So that's a little background to that. This mapping, so actually Cook and DuPage were mapped, Cook County and DuPage County are next to each other. They were mapped together. And the work was done, it was published in 1979. Everything was correlated in 1976. So when we updated Cook County, we just did that county separate. And some of the survey challenges, obviously, were parking and access points. Although I did find out when you have a government plate on your truck, you're an authorized vehicle and you can pretty much drive anywhere. So that was a lot of fun. I've never had that experience being in the city and being able to park wherever I wanted. So that helped. So there's limited observation points. The soils are really variable, the anthropogenic soils. We had the Bob McLeese was the state soil scientist at the time, and he did not want us to lose any of the prior mapping detail. So merging an urban survey with the prior mapping was an art form, I think. But I think we did it well. Mapping by landform was a challenge. The traditional surveys you map by landform. The traffic and the travel time, as Eric had pointed out, I mean, you can spend 2 hours driving. So either you leave really early and get stuck in traffic, or you leave the office at 9 and get there quicker. Either way, it ends up being the same. Our survey deadlines, we only had about 2 years to do it. The manuscript, I got the manuscript out in 2012, so that was like three years to map and collect points, do the digital maps, and then do the manuscript. The differing and the changing land uses is a challenge. Just because something is a park doesn't mean it always was a park. Just because something was residential doesn't mean it was always residential. So that's a challenge. And also a big challenge was misconceptions and bias, even within our own agency about urban surveys. So that was another challenge. So I just want to talk about that. The big misconceptions that we've found is that there's no natural soils in cities. Everything is urban land. The urban population doesn't understand soils anyway, or they don't want it. But when you think like that, you're missing opportunities. There's tons of open space. Cook County has 64,000 acres of forest reserves, and not all of it was mapped. Not to mention the parks and the schools. You're not addressing resource concerns of the taxpayers in an urban area. A lot of them are interested. Lots of groups are interested in habitat restoration, stormwater management. Depending on the city and what interpretations you want, that can change. Some cities need to figure out how to get more water, like LA, with Chicago has too much of it and try to get rid of it. Green infrastructure, there's a lot of groups that are interested in green infrastructure, so the surveys are going to help that. The stormwater, they want to know how to deal with the water instead of just putting it all down the drain. We have a potential for that project this fall, so that's exciting. You're also ignoring potential to develop new and useful interpretations specific to our urban customers, and there's all kinds of outreach and collaboration that we can do with other agencies, nonprofits, gardener groups, you name it. It's pretty limitless, and the projects can be pretty fun. And don't be afraid to explore. That was one of my favorite parts about doing the city. So you learn so much about the history. You learn about the natural beauty. This up in this corner, this is a prairie restoration right along the lake shore. We were able to dig some pits there. An urban farm in the center. Cemetery is Al Capone. That's where he's buried, so that was fun. Cemetery has offered a really, unless you got chased out like Dale did, they offer a really good opportunity to look at pits. It sounds weird, but some cemeteries would call us when they had a pit opened up when somebody passed away, and then we could go and we could get the soil description. Down in the left corner, there's a lot of really big parks. Humboldt Park is 250 acres, so these parks could provide an opportunity to hold stormwater and mitigate some flooding. This is really cool. This is along the lake shore up in the north side of the Cook County. And this in the picture is Humboldt Park, and I thought it was fun. There's a lot of culture to explore as well. So besides looking at the soil, so you learn a lot about where you live. So that just kind of goes along with misconceptions, don't be afraid, jump right in. So the way to approach it was, you need a lot of tools. Eric had talked about it. There's a lot of similarities between, I think, a lot of these surveys. A lot of it you're trying to capture the historical data. So for Cook County, we were able to get a hold of pre-settlement data, digital imagery from the Mort Arboretum. We had J. Harlan Brett's official geology maps that were really helpful. They had maps, and then he had a publication describing the different deposits. We had a characterization of the shell deposit publication. This nonfiction test, Devil in the White City, was something I decided to read while we were doing the survey. And they actually, it covers the 1893 World's Fair along with the serial killer of Chicago that you don't really hear about that was living in the city at the time, during that time. And so it talks about the history, and it also talks about the soil, because it talks about how the city was developed and the challenges that Daniel Burnham had when he was mapping out this plan for Chicago. So that was interesting. And of course, the Old Soil Survey Report, historical imagery was huge. We had historical imagery from the 1930s, so that really helped us, along with the pre-settlement data, kind of figure out what the land use was and what the soils were. It helped determine soil order and how it was used and intensity. So this just have different slides. So this surficial geology maps from J. Harlan Brett from the 30s and through the 50s. This was key to determining our landform, parent material, and associated soils. It pulled out, and we used that along with hillshade. But we used that with the hillshade to pull out sand dunes, beach ridges, the lake plains. We had two different morainic systems. We had the lake border morainic system, which was the youngest geology in the state, and then we had the lake border was up in the north, and the Valparaiso morainic system was all along, going from the southeast to the northwest part of the county. So that was helpful. The pre-settlement data, as I kind of said before, we had the digital format that allowed for the spatial analysis. We use it with present-day imagery to help determine the soil order. It's like a puzzle. So every pit that we dug or soil core that we pulled and described, it was like a piece of the puzzle, connecting the dots to what the soil would look like, what it looked like based on these different points that we got. And these imageries, as you can see, we had, this is actually a forest reserve and park at the top, but it was formerly agriculture, same as the bottom, but up top they turn into a forest reserve or park. There's also, I think there's a golf course in there. And then down at the bottom we had a former ag field, former agricultural fields that are now residential neighborhoods. As you can see, they're pretty packed in there. So having these old imagery was really helpful in knowing what it looked like before and how the soil was altered. And then probably one of my most favorite tools that we had were these, the raster data, the digital elevation models. So it's pretty flat in Illinois, and Chicago's pretty flat. And in fact, they have a lot of flooding issues anytime they get a lot of rain. They have a lot of flooding issues because they have a lot of the soil is sealed over in places, but they also have really dense till or lacustrine. It's hard to tell the difference. But up top, you see the lake border morainic system. There's the Highland, the Blodgett, the Park Ridge Moraine. There's 4 or 5. I can't remember all of them. And at the bottom, there's a little guy that I don't know where my pointer went. But anyways, at the bottom, where it says lake border morainic system, that Park Ridge Moraine is part of the lake border up top, and somehow, I don't know if it got blown out. Everything in between is Glacial Lake Chicago. There are 3 different stages. And then the Valparaiso morainic system, which is a conglomerate of a whole bunch of different moraines to the west. So we use this with the surficial geology maps to help determine landform and the types of material that were there. And I'd have to say that those geology maps were right on. They were, I mean, he did a really good job. They're really useful in helping us map. They're pretty accurate for when he did them. And it's like it was our form of pre-mapping, so to speak. And we used the National Land Cover Database. It was like an impervious surface raster data set that we were able to reclassify. And we decided what percentages were going to fall into what. So, you know, Cook County spent several $1 million wanting a product, and we didn't want all urban land delineations. You don't get any interpretations from that. It's not helpful. We could have done more if we had more time, but I guess, you know, with future projects we can address some resource concerns from there, so that's pretty exciting. So the impervious raster surface raster imagery is generated from 3 different data sources. I have high-resolution imagery, calibrating density prediction models with reference data, and the Landsat imagery. And so when we pulled that into ArcMap, we were able to reclassify the 0 to 15%, 15 to 24. Well, you can read it, but we had 5 different classifications. And I didn't add anything about the legend. I just kind of wanted to focus on methods and tools that we used. But based on those, if anything fell in the 0 to 15% category, we mapped it a natural soil. If anything was in 15 to 24, I believe it was natural soil complex with an anthropogenic, only classified to the family level, and then there may have been something else in there. I have to go in the legend and see. But we use those different classifications or those pavement percentages to help with the mapping. So we weren't just mapping all urban. And so I just have a few more slides. So in the urban survey, we have natural soils and human-altered, human-transported materials together in one survey. So it's a challenge to be able to figure out how you're going to map it, where the natural soils are. And what we found was that in the suburbs that were a little farther west, that were older, that were more established, had more natural soils, because I just think the construction methods were different as compared to back in the 70s or later. So that was pretty interesting, and that helped knowing that with the historical imagery. But these are just showing different, there's parks, the bottom corner was a home that was torn down to build a new, larger home. And you can see Lindsay and I were able to get in there, and we were able to note there was a buried A, and we can see that, and that gives us insight into that area. What types of parent material are there? The middle picture at the bottom is here we go. Down here is in a forest preserve that we were finding. So and this was in the middle of a residential area, you know, where houses were. This may have been in the same one. Up here, I think this is a disturbed area, but it looks natural. But anyways, there's all kinds of different land uses and types of soils that you're going to find in the urban survey. It's not all urban land, and it's not all disturbed. And so these are some cemetery pictures. None of this is disturbed, and none of this was either. This cemetery was in the city on a beach ridge. This one was on a western part of the county on a moraine that had some denser hills. But it's just more pictures, and I believe this is she doesn't work here anymore, but I believe it was Jennifer had the pleasure of working in all these lonely skeletal places. But yeah, it was just a combination of different things. These are a lot harder to map and to quantify, so any future projects involving this would take some time. So, and just some more different land uses. This is a farm right along Cicero Avenue that we just happen to find right here. more forest preserve is along railroad tracks, and that was a really interesting profile. Some park shots, 64,000 acres of forest preserve. This wasn't natural. This was Old Meg's Field along Northerly Island, right along the lake shore. But different land uses. It's now a prairie restoration. So all the survey can help in having a soil survey is going to help in all these endeavors. So, opportunities. An urban survey is being part of it has been fun. It's been interesting, and it's given me opportunities. I was able to go present at the SWEMA conference in Mexico City in 2015. I'm able to be a part of this focus team and hopefully help people. So that's fun, and being able to work with others that have done the same thing and exchange ideas and collaborate and on different projects and ask questions. The potential to collaborate on new interpretations is exciting. That's going to be, I think, it's going to be really important in the next few years. And as Rich has pointed out, more than 80% of our population are in urban areas. So it's going to become, I think, a bigger focus. Talked about potential for new projects. There's urban ag, and they have urban ag seasonal high tunnels now in Chicago that they're trying to get out through EQIP. So they're trying to get the name out there. There's technology we can apply, more outreach and recruitment. We can potentially change how we view soil survey progress. Rich talked about before. Do we talk about acres? Do we talk about people served when it comes to urban areas? Lots of new and exciting issues. And lastly, like I said, the limitations that we had, we had a 2-year project deadline, which we weren't able to sample any soils and send to the KSSL, with the exception there was a study in Grant Park in the 90s where they dug 5 soil pits, and they were all 5 of them were completely different classifications. So that area is where when they had the Great Chicago Fire, the rubble was just pushed into Grant Park and further out, and so there was actually layers. You could see the artifact and debris from the Chicago Fire. So, our classification is now out of date, so we have to address that in more projects. So hopefully looking forward, these MLR projects that we're able to develop can address these data deficiencies on an MLR-wide basis. We can now classify these soils potentially to a series level once we have more data down the line. We can promote them with urban partners and, collaborate to prioritize the data needs. And that's my spiel in Chicago. And I believe Randy will talk about LA next.
Thank you, Christine. Second. Hello, everybody. My name is Randy Riddle. I'm out of the Oxnard, California office, which is the Templeton MLRA Soil Survey office. I serve as the co-chair for the Urban Soils Focus Team along with Rich Shaw, and had the opportunity to work as the project leader for the southeastern part of Los Angeles County Soil Survey. I'm going to start out here just with a photo of the Los Angeles Basin. This is taken from the southwestern corner of the survey looking north across the Los Angeles Basin. And in the background, you can see the San Gabriel Mountains. And to the west, that's the Pacific Ocean. On the left, it's a broad alluvial and coastal plain area surrounded by hills and mountains with an extensive area of urban sprawl. We recently published a survey in January of 2017, so just a few months now. The area delineated in red on the image here, on my little pointer, is the edge of our survey boundary. Oh, here we go. And you can see it's kind of a mix. There's a couple hills of nature preserves, but most of the area is this grayish colored urban sprawl with highly populated urban centers. Survey's about 681,000 acres, And I ran a quick tally of the population with the census data, and there's about 9.2 million residents inside the survey area. Some of our project objectives were to adapt the traditional soil survey methodology to the high-density urban environment. We wanted to accomplish this by minimizing land use mapping and to really focus on landscapes as much as possible. And we wanted to document the current soil conditions to the best of our abilities at our mapping scale, which is at 1 to 24,000. Really the most detail that we could provide in each area. And we were evaluating the degree and extent of soil modification along the way. We approached this by identifying the natural soil sequence and the human-altered and human-transported materials. And by understanding the natural soil sequence, then we can evaluate the degree and extent of the modification. For our methods, we heavily relied on GIS. We had a couple DEM, digital elevation models available. We had both a 3-meter LiDAR and an older 10-meter hypsography, which is a digitized topo map. They were both very useful with comparing and contrasting. Now we had our aerial photography and orthoimagery. We had some older digital relief graphs, and we used PRISM as our climate model. There were several quads of the USGS geology maps available that were very handy in identifying some of the landforms that were not as visible as they are today. We had 17 pits that were sampled for full characterization at the KSSL lab, and we had countless calcimeter tests here in the office and several PSA particle size analysis tests using a hydrometer. Most of our work was done in the city parks, at schools, nature preserves, construction trenches, similar to how Eric was describing in Detroit. Any opportunity that you find while you're driving around, in addition to the more broader generalized right of entry permits that we were able to negotiate with the cities.
Sean has left the conference.
We had around 65 individual right of entry permits with the cities surrounding Los Angeles. And there was also a handful of early 1900s Bureau of Soils reconnaissance soil surveys. They were never correlated documents or modern national cooperative soil surveys, but they were handy for some general information. For our soil lines, we tried to follow the natural landforms as close as possible. The anthropogenic boundaries were used on modified boundaries where the anthropogenic landforms overtook the landscape. Only large impervious landscapes were used to delineate large areas such as near downtown where we have greater than 90% imperviousness. And lastly, our land use criteria was used as the last option for delineating the soil break.
A participant has joined the conference.
This is a nice figure here that shows the difference between our two DEM models. On the left, we have a 10-meter hypsography, which is that topographic digitized map. And this is in the pre-development landscape. And on the right, we can see the 3-meter, which is with the current landscape. This area is east of Los Angeles, and it was developed back in the mid-1980s. And you can easily see the anthropogenic, the reshaping of the hills here. And this is a repeating pattern that can be projected into other areas. So we were able to set up soil series on these cut and fill hill slope terraces. Just real briefly, we'll touch on some of the map unit name conventions. Since we can't delineate individual backyards at that scale, separate from the impervious areas, we end up with complexes in most of the developed areas. And what you end up with is a percent impervious area, which is your urban land, and then you'll have an additional 1 or 2 soil components with greater than 15% spatial coverage. And we really made an emphasis to only separate the components based on use and management, based on the soil properties that we found to be important. So an example, it looks something like urban land, Wainimi drained, San Emigdio complex with our slope class of 0 to 2%. We have some quick statistics here. We ended up with 158 soil landscape mapping units and 185 total soil taxonomic units. All these 185 soil types, those include the major and the minor components. 27 of the 185 are anthropogenic soils that meet the human-altered or human-transported taxonomic criteria. 15 of the 27 anthropogenic soils were named in the map unit names, so those are our major components. Of those, 5 of them are new anthropogenic soil series that have the human-transported taxonomic criteria. In total, we had 20 soil series that were established in the Los Angeles survey. And we had everything from natural, partially, and completely altered soils. Then we have some percent coverage areas here on the right. We had 43% impervious surfaces, 11% anthropogenic soils that meet the anthropogenic taxonomic criteria, 32% of what I'm calling impacted soils, which have less than 50 centimeters of surface amendment or human-transported materials. 12% were natural soils that were isolated onto the natural hillsides and in the nature preserves, and 2% miscellaneous areas, other than urban land, to clarify that. These numbers may look a little bit low for a place like Los Angeles, the 43% impervious land. The northern margin of the survey included basically a band of the foothills of the San Gabriel Mountains, so there was more. So this also includes a lot of natural area around the perimeter of the survey in addition to just the developed area. Some of the achievements was that the soil landscape model was strongly supported, and it worked quite well for this area. We were also able to provide soil descriptions, full component data for both the major and the minor components. So I think that's helpful, especially at our mapping scale, which is somewhat broader than some of the other surveys, where we have these longer map unit names with several components. So we have full data for everything that was mapped. At the broad scale, you can reasonably and confidently predict spatial occurrence in some of the important anthropogenic soil properties, especially as we get up into these hillsides where there's predictable cut and fill patterns for the development. And you can actually see the development era in the map unit composition. The city of Los Angeles was the first city in the United States to adopt a hillside grading ordinance, which was in 1952. And there's several versions of that document that came out, but you can actually see these small housing footprints in the older part of the city on the hills versus the more recent development in the example that we saw earlier when the entire hillsides are completely reshaped and engineered. Some of the limitations are the long map unit names, 1 to 3 components. It can appear vague without close examination or a lack of understanding of soil mapping concepts. There's a couple large delineations due to the mapping scale and the ability to separate the landforms. This is because there's some large, broad areas with little to no slope, less than 1% in some areas. And the microtopography that existed pre-development has long been leveled and scraped. So the DEMs don't really pick it up very clearly, and we have short sight lines in the field, so we were unable to separate everything as much as we wanted to in some of the floodplains. And another limitation was the artificial soil saturation from irrigation practices. Out here, there's a tendency to over-irrigate at a lot of the city parks to keep the grass green. So we had redox intermittently throughout areas and surface saturation as a result of land use practices. So that was neglected and overlooked for the mapping purposes. Well, since the survey's been published, there's been a lot of interest in stormwater management and groundwater recharge. Los Angeles, we've completely depleted our groundwater supply around here. We rely on outside water sources. So there's been a lot of work to increase the infiltration and to reclaim some of our streams and rivers and riparian areas. most of the rivers and streams in LA are concrete lined due to flooding events that were creating a lot of issues for past development. So there's been a lot of proposals to remove part of the concrete liners and to restore part of the floodplains in small sections. There were some hillside erosivity studies with the city of Culver City about a year ago, and there's recent infrastructure projects with private consulting companies that are using the survey for a high-speed rail proposal to connect downtown Los Angeles and Anaheim. There's a variety of other flood control management uses and irrigation water management for urban agriculture and city parks and things like that. So where do we go from here? We've got the Urban Soils Focus team, which is a collaboration of NRCS and our partners of people working in these areas. In Los Angeles, I have a supplement manuscript is what we're calling it. It's more of an informal type of traditional soil survey manuscript that'll have some more detailed soil profile descriptions outside of what you can find in the web soil survey. It'll have a summary of our methods and some history information and other urban soils information that we found important. A lot of the other cities in California need updates to improve substandard mapping or vague mapping in urban areas, such as San Francisco and San Diego and the surrounding areas in the Los Angeles region. There's an emphasis also on urban agriculture and community gardening. It's a popular activity in urban areas as it is in a lot of cities. And we're going to continue to collect organic carbon, bulk density, and permeability data to improve our data sets for anthropogenic soils. So some opportunities that I've had from working on this project, I've been asked to help co-chair the Urban Soils team, and like we've mentioned, and we're looking for more members or potential members to work with us with that. The picture in the top right is from the SWITMA conference that I attended recently in Moscow, Russia. So in this picture alone, it's an international group of soil scientists. There's people from France, Germany, Russia, Mexico, and I'm also in that picture from the U.S. So it's an interesting group to be involved with, and it's a really good thing that's happening with all the collaboration. The bottom right picture is from the 2014 SSSA field tour that we led at the Long Beach National Conference. This is taken in a place called Echo Park, which is just north of downtown Los Angeles. So there was an opportunity for me to lead a SSSA field tour, which was kind of a unique experience. And I highly recommend working in urban areas. You get to really travel around the cities and visit areas that you might not otherwise visit. You become more aware of your social surroundings. And I've learned a lot of local history from conversations with long-term residents that have come up and asked me what I was working on. And I've been really surprised. All ages, people are interested to know about the soils and what we're doing. And people want to do, field textures and things like that. And urban soils education, I was asked by a local nonprofit to review a laser cut steel installation that was going to be mounted on the side of a bus station, a bus stop in the San Fernando Valley, and it had had an artist's rendition of a soil profile laser cut into the steel, so that was pretty cool. And thank you all for your attention. And, next up, we're going to have Rich Shaw, project leader for the New York City Soil Survey, take over.
Okay, thanks, Randy. Last but not least, the Big Apple. In New York City, rather than a single survey, we actually had a soil survey program, and it ran from 1995 to 2011 officially. That's when we had an office there. And we had an agreement with the Soil and Water Conservation District, who instigated the whole thing. And we did multiple surveys. We did a general or reconnaissance survey at a small scale, which was part educational in purpose. We made the nice poster map you see on the right there. We did several high-intensity surveys at the lot size scale for green spaces of interest. And then finally, we did our 1 to 12,000 survey to our Surgo standards. And we also did on-site investigations. We did public outreach to raise awareness of soil in the city. And we actually had a very successful volunteer and internship program. We won a national award in 2009 for that. So we're very proud of that. One of the most important soil survey objectives is to meet the local needs, and the Soil and Water Conservation District helped us set up a technical advisory committee, and the TAC helped identify the user's needs. It helped provide some guidance in operations and logistics in the city, which is important, reviewed the progress, disseminated information. And one of the specifications of the users was that the survey provides some useful information on our human altered or human transported or fill soils. They wanted information on physical, chemical, mineralogical properties, drainage class. You know, the old Udor fence just wasn't cutting it. So, a little background: New York City is made of 4 islands and a peninsula, not very big, so there was limited room for expansion, and this led to the filling of wetlands, expanding the shoreline. A lot of this using waste materials. And that explains a lot of the soil types and patterns in the city. It was also initially settled by the Dutch, who were pretty good at what they called reclaiming wetlands. And the city is pretty old as far as others in the U.S. go. It's also got a pretty diverse geologic, geomorphic, and soil parent material distribution. The area was essentially all glaciated during the Wisconsin Ice Age. We've got 3 different physiographic provinces, and a terminal moraine running east and west through Staten Island, Brooklyn, and Queens. Glacial Tilden north of that, and an outwash plain to the south of that. I guess you could say the key to urban soil survey is understanding human alteration in your area. And for us, the most important reference was this 1902 USGS New York City folio, specifically the surficial geology map. And we really use that as a guide to original parent materials in an area, help us decide whether an area was filled or not. And we actually used it to differentiate some of the urban land map units. And I guess our field methods, the number one was doing your homework before going out in the field. Get to know the natural soils and landscapes. Review the reference materials before you go out. And we had some pretty good contour, 2-foot contour interval topo maps from the Parks Department. We had some aerial photography from the city. We didn't have any DEMs at the time of the survey. And we actually used the good old stereo pairs to do our delineation. And eventually we were able to recognize some patterns, associate certain types of fill with certain superficial geology, landscape position, or vegetation, and come up with some sort of a soil landscape model. A couple observations we made: that there was a uniformity in the fill in the larger contiguous open spaces, which really made mapping the fill to the series level possible. And the smaller parcels, usually the ones in the residential areas, was really too much variability. They were beyond the scope of the survey and probably better suited to on-site investigation. Some of the soil landscape units could reflect either landforms, parent materials, or in our case, we actually differentiate some based on land use and land cover. Sometimes the parent material, land use, and land cover can change without a change in the landform. So. And in our initial soil survey, we had a scale of 1 to 12,000. Our minimum size delineation was about 1.5 acres. We ended up with 236 map units. We identified 37 natural soil series that is soils and naturally deposited materials. We set up 4 new ones in New York City, and we also identified 29 different types of human-altered or human-transported soil, and 27 of those we set up in New York City. We differentiated 5 different types of fill. We've got the human-altered, human-transported class listed there, clean fill, dredge, construction debris, some of the coal and fly ash, and solid waste landfill. And we had 6 substratum phases for urban land map units, which we got from that USGS surficial geology map. And based on our 1 to 12,000 survey, about 63% of the city is paved surface, about 28% fill soils, about 9% natural soils, and 1% other types of miscellaneous areas, rock outcrop, beaches, etc. We did quite a bit of lab sampling, over 100 pedons, and we had quite a few special projects, a lot of them involving trace metals. Most recently, I was able to calculate total carbon stocks in the city to a 1 meter depth, and that includes soils under the pavement. So we've got a whole lot of really good lab data for the city. Some of the soil survey uses, revegetation, restoration, matching vegetation to the soil conditions, stormwater management, getting the right hydrologic soil group was most important, and resource inventory, identifying special habitat, and like I said, measuring carbon stock. We're very proud of our cooperator or partnership list in New York City, people that we worked it through the time of our program. We've got municipal, state, federal agencies, colleges and universities, nonprofits, and others. A few highlights of those partnerships include hosting the International Urban Soils Conference in 2009. The district and Queens College, we had assistance from the Parks Department and National Park Service. Our photo there shows our rubber glove texture contest that we had in Central Park. And assisting with research projects with universities that benefited the agency as well as the students involved in the colleges. Another big highlight, NRCS serves as one of the core partners of the New York City Urban Soils Institute. The Institute has really grown from the demand for soils information and services in the city, and you could take that as an indication that our efforts to raise soil awareness in the city have been successful. In 3 years, the Urban Soils Institute has been working on several international partnerships of its own, assisted with planning the last SUTMA conference in Russia, had to turn people away from its first soil symposium last year and is planning a bigger one this year. So our soil survey program may not be there physically anymore, but we still have a role with the Urban Soils Institute, which expands on our original program. So to summarize, I think our program has been successful in raising awareness of soil science and establishing NRCS presence in the city. I think we've been able to provide some useful information. I think you can't underestimate the value of partnerships, especially in the city where there are so many potential partners, and it's a way to get a lot more accomplished, make some valuable connections. As far as opportunities, I think urban soil science is really one of the final frontiers of soil science, and the world is urbanizing, so there's a lot of opportunity out there. I've been able to do a little international travel. I can say our agency is highly respected by our international colleagues, and I think Randy and Christine and Louis will back me up on this. Also been able to contribute some writing and editing and participate in some different types of activities. I think most importantly for all of us working in urban areas, we all end up with some really good stories to tell and some unique experiences. And in New York City, I think some acknowledgement is due to the originators of our program. The district started it all. Tyrone Goddard and Louis Hernandez were the NRCS folks who really had the vision and began the work. And Ray Bryant and John Galbraith from Cornell were really important. The Connecticut Soil Survey Office wrapped up the work, and our partners made it a lot bigger than it would have been. So I think I will leave you with mostly smiling faces of the people that did all the work in New York City. And thank you all for your attention.
All right, outstanding. Let's move on to some questions and answers. And again, for those listening online, you can enter your question in the Q&A pod, and then we'll address those in the order they come in. So the first question comes from Joe. How did you deal with or find or identify underground utilities before digging?
This is Christine. The state purchased a Pipehorn utility locator that they sent me to a Julie training. The contact person from Julie said that he really didn't want to hear from me from every hole that we dug. So he gave me the training and said, you guys don't need to call, you guys know how to use it. And so we just brought that out with us every time we wanted to dig.
Hey, this is Randy out in Los Angeles. We use 811, the phone number, which is the US Dig, well, it's called Dig Alert here. I think it's called USA Dig Ticket. And they notify all the utility companies in the area. And if you pre-mark the area with white paint or flags, they'll come out and clear the sites or mark where the utilities are located. I think a lot of states have something similar to that in place.
Yeah, and there was just a comment that, some states require to call that number that they have and provide the coordinates before you dig a pit, and that goes by various names across the country. Another question by Edwin Muniz, other than the known studies in Liberty State Park in New Jersey, how many use geophysical studies such as ground penetrating radar and electromagnetic induction to map thickness of anthropogenic soil materials?
Well, we did that in New York City. A couple of examples, I know they looked at the depth of fill over tidal marsh. It was, in this case, it was pretty sandy dredged fill, so there was a pretty good distinction between the sandy dredged fill and the tidal marsh, and came up with a depth of, I think it was about 16, 17 feet of dredged fill.
How about some of the other areas, LA and Chicago, Michigan, Flint?
No, we didn't use the like a GPR or anything. I'm hoping that in this next few years, some of these special MLRA projects, I can potentially use it for better characterization.
Sounds like some potential, Edwin.
Up in Detroit, Wayne State University did run some studies with the EMI. What they found, they were only really accurate down to about 20 centimeters up here, and only if there were artifacts for it to pick up. So it wouldn't give us the full depths on a lot of stuff.
Back in the early days of New York City, we were asked to map human refuse or landfills with garbage and that type of things. And early in this process, we didn't know how to manage that type of situation. So we use geophysics, the GPR, and the EM to collect data like thickness of the fill material over the garbage, things like that. We also use it to determine depth to bedrock in Central Park. We use it in Jamaica Bay in some areas to determine depth to fresh water table. depth to tidal marsh tool.
All right. Let's go on to the next question from James, who says, I am a landscape architect. What are you learning that will help me when I am on an unmapped site and doing a soil survey of a small site, less than 1 acre? Tools, nomenclature, mapping, guessing between pits, etc. I typically use a Dutch auger and get test holes between 1 to 4 feet deep. So certainly, one thing that comes to mind would be the, stormwater, different practices, the kinds of soils that are suited to each of those practices, maybe. If something comes to mind, what do the rest of you say?
The question is, what did we learn? Say that again. I'm sorry. I can't see any of these, so I don't.
So what have you learned from the urban surveys to help a landscape architect is essentially the question.
Well, let me jump and share a few comments. This is Luis Hernandez. One thing that we learned is that in urban soils, if you are doing site-specific type of projects, you need to increase the intensity of holes or excavations because the spatial variability is extremely high. So in one area you can get a soil material with a lot of concrete, which will increase the pH, base saturation, and then you can move to another area where you may get something different. The other thing is that vegetation is if you are doing if you are making let's say a landscaping project and you I guess that you plan to use native vegetation, you want to look into the chemical and physical soil properties before you use native species. It is again the humans create a soil environment very challenging for native species.
Yeah, this is Rich. Let me weigh in on this. If you do have a soil survey in the area, the survey will generally cover the range of soils in that area. So I may not tell you what exactly is in your site-specific area, but at least you could look in the survey and sort of be familiar with the ranging characteristics for the area.
All right, there's a couple of questions here dealing with the scale of the surveys. Did you establish the scale starting the survey at the start of the survey, or did you estimate it and then fix it while you were doing the survey? And maybe talk about what factors were used to decide whether the survey is going to be mapped at 1 to 12,000 or 1 to 24,000 scale.
This is Rich. I guess I could talk about what we did in New York City. We, like I said, we had the Technical Advisory Committee. We did surveys at different scales. I guess what we were looking at was what sort of resolution or what was the minimum size delineation we wanted at the different scales. So it was pretty much after discussing with our Technical Advisory Committee that we decided on which scale to use for which survey.
Anyone else?
Well,
yeah, this is Randy in Los Angeles. I'll just add that in Los Angeles we had the preset scale of 1 to 24,000. In the urban areas we tried to get as much detail as we could down to that scale, but there were some areas where it's not, you can't quite reach that resolution, and because some of the environmental factors or variability in the landscapes that we were looking at. So it's not as consistent, at least in the Los Angeles survey, as in how we typically would map on a scale basis.
In Chicago, we had the scale was already it was set. Like we mapped at 112, and because half of it was already mapped, we needed to keep it consistent at 1 to 12, and everything else around here is 1 to 12. So.
All right, another question dealing with saturated hydraulic conductivity. So some mentioned they were measuring KSAT, hydraulic conductivity, and there's a question about how that was measured, and did you go by horizon, by depth? Where that was done, did everybody use an amusometer?
I'll comment on that. I hope anybody wasn't confused listening to mine. I was referring to future projects that I'm planning in the future was to get more on-site data for KSAT values. In LA, we used the pre-established standard breaks.
In New York City, we used the infiltrometer quite a bit. We used the Cornell sprinkle infiltrometer. We had a little study in the Bronx where we were trying to get the hydrologic soil groups right. So we used the infiltrometer looking at infiltration on different land use types.
All right, another question about the hot soil series, the human-altered, human-transported soil series. Is there a list of hot soil series available?
That sounds like something we should put on our website. I don't know that there is one, but we could get it together.
I don't know that there is one, but there is a way to query off the soil classification page based on the human-altered to human-transported family classes, and that can narrow the list down substantially, assuming that all the OSDs in the previously done or completed surveys is updated.
So I'll just put that in the chat for everyone. And they can copy that link and look at it. Another one from Bill, observations of a consulting soil scientist. Many urban jurisdictions restrict stormwater management, geotechnical, on-site wastewater treatment to natural soils. Knowledge of the historic mapping units is often critical to the soil use. Urban jurisdictions use the soil map for regulatory purposes on scale of 1 inch to 30 feet. Regardless of mapping scale, it needs to be informed. Urban land is useless. Complexes are better. NRCS should promote the need for specific site investigations. Warning labels on the website have minimum impact. Need more practical soil scientists to assist. There are opportunities out there. So what is the consensus of the panel or thoughts from the panel about doing a more intensive, more on-site type work in urban areas?
This is Luis. My 2 cents to the question is, we conduct medium intensity soil survey. We have done some high intensity soil survey just to demonstrate what we can do in regards to soil survey. But I think that it is a clear line in regards to where we stop. Now we have other program within the soil survey program that we call technical soil services, where any customer out there, if they need that we go out there and conduct a soil investigation for a small area, yeah, that can be done. We have the mechanism to do that. But in regards to doing intensive soil survey for all over the country, a festival is not our business. I think that this is where the private sector comes to play. And again, I don't think that we have all the horses and the resources to do something like that. I mean, in a big, thing, like even doing a big city, But we're in the business of medium intensity. We conduct the soil survey. We provide information, and the users out there, here's a tool that you can use to do the initial assessment, and then the person needs to determine if the assessment need to go deeper, Again, private sector is out there to help out with that. But again, NRCS through the Technical Soil Services program can assist with that too.
So another question from Louis. So what do you do when you have unique soil units which you can't describe, perhaps because it's totally paved or built over?
This is Dean. In that case, for us, we tried to find any open lot or park or schoolyard that we could get, identify those, even if they were an acre or less or an acre and a half. It gave us clues to the parent material, and then we would at least try to complex it with at least a disturbed or anthropogenic soil, even if it was like, an urban land complex with an anthropogenic soil, that we try to do that. I mean, we're limited in how we describe it because you can't, obviously. The best we can do is use the material that we have, the historical stuff, and look at parks in the area that'll give us clues to parent material and drainage patterns.
All right, there's some comments in here from David in Texas Tech University. It seems as though very few proximal sensors were used in these surveys. I'm wondering about the use of PXRF, visible NIR, DRS, EMI, and or GPR. They would seem to provide great data for your uses. Also, it seems that classification of urban soils is way behind our European colleagues who have technosols and anthrosols to describe human impacted soils at the order level. So we want to address those two items.
I could talk about the first one. I agree that there is a lot of potential for XRF and some of those other instruments there. We did use GPR to some extent in our survey in New York, but we didn't have PXRF at the time, and I agree they would come in very handy in mapping in urban areas.
And I'm hoping to utilize those tools if I can get, if I can have access to them in these projects that address the data gaps in these anthropogenic soils in Chicago, to bring not only up to current taxonomy, but collect pertinent data that we can use.
And I see David put in the chat, if you need access, call me.
We might do that.
Somebody want to speak to the classification aspect of that?
Yeah, I'll ask about the classification. That with the Urban Soils Focus team, that's one of our charges, is to evaluate and provide basically suggestions for improvements on the current state of the human-altered, human-transported classification. So I think, that was the first cut in the 12th edition, and, we can start improving it and moving forward. So if you do have suggestions, please let us know if you have specific items.
Without any questions, we have an opportunity to enrich the USA soil classification system. But folks, if you look back maybe 20, 30 years ago, we were far behind on how to classify this type of soils, with soil taxonomy. But Dr. John Galbraith, he has done an amazing job incorporating taxonomic classes in soil taxonomy so we can classify this type of soils. And that is available in the last edition of the Keys of Soil Taxonomy. In addition to that, in the early days, we didn't know how to describe soils containing brick concrete, glass, you name it. Again, the universities and our partners, working with us, working together, we came up with a good system to name, to describe, and classify anthropogenic soil. Again, I'm not saying that we are done. What I'm saying is that we have come a long way thanks to the partnership effort, and we are going to enrich our soil classification system as we move forward with this type of work.
All right, another question from Matthew. Did anyone use the new M master horizon in profiles or to populate some other component?
This is Christine. No, as I said, when we were operating on the previous taxonomy version, so we didn't. After we were finished, the updated keys came out, so it quickly made everything out of date. So we'll have to address those.
Hey Matthew, this is Randy. We populated the restriction table as manufactured at 0. So that was one way to capture that.
There's a question from Barrett. Have you come across issues with chemically contaminated or toxic soils during these surveys?
Not that we know of.
All right, we'll let that one go, I guess.
I think most of the areas that were drastically contaminated were really we couldn't get access to the areas, so.
And another question from Lewis. Have you tried a soil classification with WRB as well? Does the soil taxonomy communicate well all the important urban soil characteristics? Both classifications are equally useful to survey urban soils, or are both classification systems equally useful to survey urban soils?
We never tried the WRB in our classification, but I think the latest soil taxonomy, it might have borrowed a little from WRB, and I don't know.
Well, certainly part of the National Cooperative Soil Survey, as a group of that, we decided we would use soil taxonomy and not WRB. But perhaps that'd be something for somebody to look at, both of those systems, and if there was some divergence or how we would use that in our soil database or store it in our soil database, that we're just not set up to really use WRB. That might be a good point to turn this over to Luis for some closing comments. Luis, I'll turn it over to you.
Okay, thank you, Sean. First of all, I want to say thank you to everybody, especially to the speakers. I think that you guys did an outstanding job putting together the presentation and sharing information with the audience. The Natural Resources Conservation Service National Cooperative Soil Survey Program provides the umbrella to bring partners and cooperators to the table to conduct this type of work. As you already noticed, this type of work, we never completed this type of work alone. This type of work has been completed, and I think that we'll be on that route to partnerships and collaboration with entities such as soil and water conservation districts, universities, city agencies, state agencies, federal agencies, whoever is out there that want to get on the table to work with us and help us to conduct this type of work. Some of you, I know that some of you are not with NRCS, so you may be asking, where do I find information that you guys are talking about? And the answer is the Web Soil Survey. So, for example, you go right now on Web Soil Survey, you're going to find, the soil survey information of New York City, Detroit, and Chicago. And I'm guessing that Los Angeles is already available on the Web Soil Survey. So for population, the projections are that population is going to continue growing. So urban sprawl is going to continue expanding. So I think that society is going to need our help as we move forward. So I encourage and challenge each of you to become familiar with this type of work. One way, as Rich pointed out at the beginning, is through the urban focus team. So again, please get engaged. So with that, I send it back to you, Sean.
All right. Well, thank you to our panel for your time and effort to make this presentation. And thanks to all the participants for joining in. We had well over 150 people join today's webinar. The on-demand recording of this webinar will be available on our National Soil Survey Center YouTube channel within a few business days. So feel free to let your colleagues know about this opportunity. This concludes our webinar presentation.